For the last few years, it has almost seemed like every news we hear about space is targeted at the planet Mars. Meanwhile, Mars cannot be inhabited by humans because of its toxic environment, but scientists are trying very hard to find a way to make it habitable. Stick with this video to find out the extraordinary way scientists are ensuring we'll have oxygen on Mars. The Martian atmosphere. Let's start by delving into some science. The air on Earth contains a mixture of several gases, but only one of them is beneficial to humans. The other gases help keep life on Earth thriving. However, only oxygen, which makes up 21% of our air, is needful to humans. The most abundant gas in the Earth's atmosphere is actually nitrogen, and there is some trace amounts of carbon dioxide thrown into the mix. This combination is what works for humans, so when you switch up the combination of gases in any air we have to breathe, it's usually disastrous. Comparing the Martian atmosphere to Earth's atmosphere, you'll realize that Mars has 99% less air than Earth. A lot of this has to do with the sheer size of the planet and the strength of its gravity. Now, it's one thing for the air to be thin, it's another thing for it to be completely toxic. Carbon dioxide, which is the most prevalent gas in that thin atmosphere, accounts for the whole 96% of the atmosphere. In contrast, the amount of oxygen in the air on Mars is a mere 1%, far too little for humans to exist. Without a spacesuit providing oxygen, trying to breathe on Mars' surface would be fatal. This is a horrible idea. At about the same time, you would start to suffocate and start to feel the effects of the low air pressure. With all the space exploration that we dream of doing and Elon Musk's ideas to colonize Mars, we need a solution. How exactly could we get enough oxygen into the Mars atmosphere? Looks like NASA has an answer for us. Meet Moxie. 100 million miles away on the red and dusty surface of Mars, there's a tiny gadget that's attempting to simulate the effects of a tiny tree being planted on the planet. This gadget isn't beautifying the landscape as trees do on Earth, but is doing something way more practical. Some say it's the size of a toaster, others say it's the size of a lunchbox, but either way, this tiny thing is unprecedentedly producing oxygen. Since April 2021, roughly 2 months after it landed on the Martian surface as part of NASA's Perseverance Rover and Mars 2020 mission led by MIT, Mars Oxygen In Situ Resource Utilization Experiment, or Moxie, has been producing oxygen from the red planet's carbon dioxide-rich atmosphere. According to the research, reports published in Science Advances journal, by the end of 2021, Moxie was able to produce oxygen on 7 experimental runs. The 7 rounds were carried out in different atmospheric conditions, including day and night, and at different Martian seasons. The small gadget impressively produced 6 grams of oxygen per hour in each run, which is the same amount a small tree produces on Earth. With this success, Moxie's engineers may just produce a larger version of the gadget to ensure that even a small astronaut test trip to the planet has enough oxygen to survive. Right now, Moxie's consistency in output is an encouragement that giant strides can still be made in the human exploration of Mars. Moxie has also found a way into the history books as being the first instrument to exemplify in situ resource utilization, which is the concept of using a planet's resources to create resources that would otherwise need to be carried from Earth. The Moxie Deputy Principal Investigator and a Professor of the Practice at MIT's Department of Aeronautics and Astronautics, Jeffrey Hoffman, claims that this is the first demonstration of actually using resources on the surface of another planetary body and chemically transforming them into something that would be useful for a human mission. Moxie's achievements. Moxie's original design made it as compact as possible so it can fit inside the Perseverance rover. and this has made it able to only run for a brief period. The mission's priority affects the rover's perceived responsibility and determines when the gadget starts up and shuts down for each experimental run. However, to produce more oxygen, a larger instrument would have much larger units that could run at all times without starting or stopping. Moxie has shown that its design, regardless of scale, can reliably and effectively convert the thin Martian air into usable oxygen. It does this by drawing in Martian air and passing it through a fitted filter to eliminate any impurities. Next, the filtered air is passed through the solid oxide electrolyzer, or Moxie, a component of Moxie, created and manufactured by Oxyon Energy, after which it is split into oxygen ions and carbon monoxide by electrochemical reactions. The oxygen ions are then separated and recombined to create breathable molecular energy, or O2, which Moxie then analyzes for quantity and purity before releasing it safely back into the atmosphere along with carbon monoxide and other atmospheric gases. In each of the 7 times that Moxie has run, the device took a few hours to warm up before producing oxygen for an hour before being powered down. Each time, a run was aimed at testing Moxie's ability to conform to changes in the planet's atmospheric conditions, such as various times of the year and various times of the day. The engineers observed that the atmosphere of Earth is way more stable than that of Mars, and therefore Mars must be studied carefully to determine how best to tweak the instrument's design to get her for every atmospheric fluctuation. Throughout the year, the temperature can vary by 100 degrees and the air density can vary by a factor of 2, and this could likely affect a larger instrument's effectiveness if adequate runs are not carried out with Moxie. Moxie has so far demonstrated that its only disability is producing oxygen at dawn or dusk. This disability only exists because testing has yet to be run during those particular times due to their particular temperature signatures. However, the engineers are currently lab testing a new process to allow Moxie to run at those times of the day to accomplish the goal of demonstrating its ability to run at any time and in any season. The next steps. As was said earlier, Moxie's production capacity must be improved as it continues to produce oxygen on Mars. This is both to increase the volume of oxygen that can be produced, as well as improve the gadget's ability to work optimally in more extreme conditions, such as the spring months, which have a high atmospheric density. The team's schedule shows the next planned run to hold at the maximum density of the atmosphere during the Martian year to test Moxie's actual limit by pumping for as long as possible. That is, the run will continue past an hour as has been obtainable, but Moxie will rather produce as much oxygen as it possibly can. This will show the true limits of the instrument. Additionally, they will keep an eye out for indicators of system wear and tear. Moxie's inability to operate continually like a real system would be hinged on being one of the 7 experiments on Perseverance. This is the reason of its constant starting and shutting down, which may result in heat stress on the system that could eventually cause a system failure. Moxie's ability to function properly in the coming years, despite switching on and off frequently, will prove the likelihood of a continuous system's success. Moxie's truest effect will be seen in the scaling up of her production capacity, as a multi-year human mission to Mars requires at least 4.5 to 6.5 pounds of oxygen would need to be created per hour. Astronauts already have to transport a lot of stuff from Earth, like computers, spacesuits, and housing, to enable a human voyage to Mars. Making their own oxygen before they arrive would definitely help them be ahead of schedule. Moxie's parent. Moxie didn't just fly to Mars all on its own, but was part of a larger device called Perseverance. NASA's Mars 2020 mission is responsible for the introduction of the Perseverance rover. Percy, as it is affectionately called, is on the lookout for past or current life on the red planet. The rover will perform several scientific experiments during its mission that is planned to last at least 2 years and will tick off all the objectives of NASA's Mars exploration mission. For humans to live on Mars, we must have enough oxygen to survive. However, the Martian environment has only 1% oxygen, which can be fatal to humans. NASA's solution was to send an instrument called Moxie to Mars with the Perseverance rover. Moxie, small as it is, has managed to create substantial oxygen in 7 rounds of trial. It does this by splitting the Martian air into oxygen and carbon monoxide ions and then recombining the oxygen ions into breathable O2. Moxie represents hope for the quest of humans to the red planet. The oxygen that might be taken for granted on Earth is something to be celebrated somewhere else. Who knows what else we will have to create for our dreams of exploring the universe to become reality? Let us know what you think about Moxie and the human Mars endeavors in the comments below.